So 3D, let's do some extra questions. For the first question, find the vector in the Cartesian equation of the line through the point 5, comma 2, comma minus 4, which is parallel to another vector 3i plus 2j minus 8k. Find the vector equation of the Cartesian equation of line through a point parallel to this. So it's x, y, z. So x minus 5 by 3 is equal to y minus 2 by 2 is equal to z plus 4 by minus 8 is equal to lambda is the equation of the line. This is Cartesian form. The vector form is r vector is equal to the point vector, which is a vector plus lambda times b vector, where this is a vector and this is b vector. So 5i plus 2j minus 4k plus lambda times the b vector, which is also the denominator, or the one which is on the top, which is 3i plus 2j minus 8k, and that is the vector form. So that answers the first question. Okay, and so let's go to next question. Second question. Find the equation of the line passing through 2 points. It's minus 1, 0 and 2, and 3, 4 and 6. Call it x, y, z. This is parallel to this, so x plus 1 by 3 plus 1 is equal to y minus 0 by 4 minus 0. It's x minus x1 by x2 minus x1. I call it as x1 by 1 z1, x2 y2 z2. The formula is x minus x1 by x2 minus x1 is equal to y minus y1 is equal to y2 minus y. Z minus z1 by z2 minus z1. So it's x plus 1 by 3 plus 1 is equal to y minus 0 by 4 minus 0 is equal to z minus 2 by 6 minus 2. So x plus 1 by 4 is equal to y minus 0 by 4 is equal to z minus 2 by 4. This is the Cartesian equation of the line. You can write equal to lambda, or you can just leave it like that. This is the Cartesian equation of the line. And so the r vector is equal to a vector, which is minus 1i plus 0j plus 2k plus lambda times 4i plus 4j plus 4k. So this is an equation. Another way of, you can write this, and you can also say cancel this with 1 1 1, because they are ratios, and the line can also be represented as minus 1i plus 0j plus 2k plus lambda times 1i plus 1j plus 1k. So then it's this or this. I would write both answers, okay, to be safe. So next is next sum. So let's look at this question here. Show that the points whose position vectors are collinear. You have to show the 3 points are collinear. Okay, so this is sum number 15 in page number 28.10 in R.D. Sharma. So the position vectors are minus 2i plus 3j, which means plus 0k. And then I plus 2j plus 3k. And 7i plus 0j plus 9k are collinear. If they're collinear, all that you have to see is one is lambda. Just mark these points here. Minus 2i plus 3j plus 0k. I plus 2j plus 3k. And 7i plus 0j plus 9k. Okay, so then this is, to prove it's collinear, find this vector and this vector. If one is lambda times another, then they're parallel. But you know that if AB is parallel to BC, since B is the common point, they'll become collinear. Okay, so then find AB vector, which is x2 minus x1 into I, which is 1 plus 2 is 3i. 2 minus 3 is minus 1j. 3 minus 0 is 3k. You got this vector, AB vector. Now find what is BC vector. It's x2 minus x1, so 6i minus 2j plus 6k. And you can say, you can take a 3 out, or a 2 out, sorry, a 3i minus j plus 3k shows that the lambda is 2. AB is 2 times BC, AB is lambda times BC. And Therefore, you can say that AB is parallel to BC, and B being a common point, it becomes collinear. So that completes that sum. Let's go to the next question, which is the 16th sum in Adishama. Find the Cartesian and vector equation of the line which passes through the point 1, 2, 3, which is parallel to a line, and the line's equation is given to be minus x minus 2 by 1 is equal to y plus 3 by 7 is equal to 2z minus 6 by 3. I only need the directions of this line. But I can't take the denominators because it's not in the right format. The line has to be in the form x minus x1 by a. So if I convert it in that format, this line will become x plus 2 by minus 1 is equal to y plus 3 by 7. That is not changing. The 2 should not come. So z minus 3 by 2. So then, so that you get in the form x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So then, therefore, you know the directions are minus 1, 7 and 3 by 2. And considering an arbitrary point x, y, z, it's x minus 1 by minus 1 is equal to y minus 2 by 7 is equal to z minus 3 by 2 is the equation of the line in Cartesian form. And suppose they ask you r vector is equal to a vector, which is 1i plus 2j plus 3k, which is the point, plus lambda times b vector, which is the directions of the parallel line, which is also in the denominator, which is minus 1i plus 7j plus 3 by 2k. So that completes that sum. Let's go to 17th question. I'm doing only selected sums from Adishama. The Cartesian equation of the line are 3x plus 1 is equal to 6y minus 2 is equal to 1 minus z. Find the fixed point through which it passes through. So they're asking the point through which it's passing through, and the direction ratios, and also its vector form. First of all, an equation cannot be in this format. It has to be x minus x1 by a. You can't have a 3. So dividing by 3 will be x plus x plus 1 by 3 by, so then you've taken a 3 out, so you can write this 3 as 1 by 3. So here you're taking a 6 out, so y minus 2 by 6 will be 1 by 3, and the 6 will become 1 by 6 here, and here it has to be z minus 1, therefore minus 1 here. So therefore I get this format to be x plus 1 by 3 by 1 by 3 is equal to y minus 2. So converting it in the right format is necessary. Okay, so once you convert this into the right format, 17th question. Okay, so therefore you get okay, you're taking the 6 out from this, to be y minus 2 by 3, and 6 comes as 1 by 6, yeah, and a minus 1. So then therefore the points through which it's passing through will be, it's like x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c, where x1, y1, z1 are the points, which will be minus 1 by 3, a 1 by 3 and a 1. That will be the point. And the parallel vector is what is the denominator, which is 1 by 3, a 1 by 6 and a minus 1. A 1 by 3, 1 by 6. This is the direction ratio of this line, of the parallel line. Okay, so then it's 1 by 3, 1 by 6 and minus 1. According to Adishama, they have written it as 2 is to 1 is to minus 6. They just multiplied the entire thing with a 6 to get the direction ratio. It doesn't matter, you can even leave it like this. So this is the point and this is the direction ratios of the line. They're asking you for a vector form. R vector is equal to, this is A vector and this is B vector, and R vector is equal to minus 1 by 3i plus 1 by 3j plus 1k plus lambda times 1 by 3i plus 1 by 6j minus 1k. So that will be my vector format. And the direction ratios can also be multiplied by 6. If you want to do that, you can do that. Otherwise, leave it like that. Otherwise, the next answer will be minus 1 by 3i plus 1 by 3j plus k plus lambda times multiplying with 6, it will become 2i plus 1j minus 6k. So this is also one answer, this is also another answer. Whichever answer they want, they can take it. Okay, so that's a nice sum, and we've written it in vector form too. So next is the angle between two lines. You know that it's find the angle between two lines. Okay, let's take an example. Example 2, or let me do some exercise sums. That's easy. Yeah, so let's take an exercise sum. Exercise page number 28.16. We have a sum which is the fifth sum. Show that the lines x minus 5 by 7 is equal to y plus 2 by minus 5 is equal to z by 1, and x by 1 is equal to y by 2 is equal to z by 3 are perpendicular to each other. First of all, check if this is the right format. X minus x1 by a is equal to y minus y1 by b is equal to z minus, yeah, both of them. If it's x minus 1, it's x minus 0 by 1, y minus 0 by 2, z minus 0 by 3. And all you need to find if they are perpendicular is only this b1 vector and b2 vector. b1 vector is the direction of this, which is 7i minus 5j plus 1k. And a b2 vector in this is 1i plus 2j plus 3k. And if dot b1 and b2 is equal to 0, dot product, then it means it's perpendicular. It's a 7i minus 5j plus 1k has to be dotted with 1i plus 2j plus 3k. So it's 7 minus 5 to 10 plus 3. Can you see 10 minus 10 is 0, and therefore you get b1 and b2 to be perpendicular, and therefore these two lines are perpendicular. So that's sum I wanted to try. And then the next sum, show that the line through the point, the third sum in the same page, line through the point 4, 7, 8 and 2, 3, 4 is parallel to a line through the point minus 1, minus 2, 1 and 1, 2, 5. You just need the direction of this and direction of this. Is one is lambda times other, then they are parallel. So to find the direction of this is x2 minus x1, which is minus 2i minus 4j minus 4k, and the direction of this is 2i plus 4j plus 4k. Can you see one is lambda times other by where lambda itself is minus 1? That shows that the two lines are parallel to each other. So then let's go to next question. So perpendicular means you have to dot product, parallel means you have to find the directions and say that one is lambda times other. The next sum that I would like to do is to find angle between the two lines. You only need the directions, and so you can dot product the directions by magnitude of this and the magnitude of that. Okay, let's take this sum, which is sum number 21. If the lines x minus 1 by 3 is equal to y minus 2 by 2 lambda is equal to z minus 3 by 2, and x minus 1 by 3 lambda is equal to y minus 1 by 1 is equal to z minus 6 by minus 5 are perpendicular, find the value of lambda. You know the denominator is your b1 vector, which is 3i plus 2 lambda j plus 2k. The b2 vector is 3 lambda I plus 1j minus 5k. And b1 dot b2 is equal to 0. Therefore, it's 9 lambda square plus 2 lambda minus 10 is equal to, 9 lambda plus 2 lambda minus 10 is equal to 0. 11 lambda minus 10 is equal to 0. 11 lambda is equal to 10, and lambda therefore is 10 by 11. So hence you can find the value of lambda. So if they ask you questions like that, it's very simple. So which sum did I try? I tried the 21st question, where is it correct what I did? The question here shows a minus 3. Other than that, everything is fine. So this becomes minus 3, so it becomes minus 9 lambda. So then for minus 7 lambda, and therefore 7 lambda is equal to minus 10, and then lambda is equal to minus 10 by 7. So I wrote the question wrongly. So that's about it. And so next is so next sum that I tried in the class. So angle between two means just dot product the b1 and b2 by magnitude of b1 and b2. to show that, okay, this is a very good sum. Sum number 1, example 1 in 28.20 Nadi Sharma. Show that the line x minus 1 by 2 is equal to y minus 2 by 3 is equal to z minus 3 by 4, and x minus 4 by 5 is equal to y minus 1 by 2 is equal to z intersect. You have to show that they two intersect each other. Okay, and so then what you do, you write this equation is in the right format, is equal to lambda, but this equation is not in the right format. When you say equal to z, it's in z minus 0 by 1. That's the thing you should know. When you say z, it's z minus 0 by 1 is equal to mu. So find what is x, y, z from the first equation and what is x, y, z from the second equation in terms of lambda mu. X from the first equation is 2 lambda plus 1, y is 3 lambda plus 2, z is 4 lambda plus 3. The x from the second equation, x is equal to 5 mu plus 4 and y is equal to 2 mu plus 1 and z is equal to mu itself. So since you got this, you know that there is an x and can be equated. A 2 lambda plus 1 is equal to 5 mu plus 4. Take one of those equations and equate it. Okay, 2 lambda minus 5 mu is equal to 3 is my first equation. Take the second y's and equate. 3 lambda plus 2 is equal to 2 mu plus 1. 3 lambda minus 2 mu is equal to 1 minus 2, which is minus 1. Solve these two equations and you have to multiply this with the 3 and multiply this with the 2. So it's 6 lambda minus 15 mu is equal to 9. 6 lambda minus 4 mu is equal to minus 2. A minus plus and a plus. So it's minus 11 mu is equal to 11. So mu is equal to minus 1. You got a beautiful mu. You can take that and substitute and find the value of lambda. 3 lambda minus 2 into minus 1 is equal to minus 1. 3 lambda plus 2 is equal to minus 1. 3 lambda is equal to minus 3. So lambda is equal to minus 1. So hence you got lambda and mu to be minus 1. And so when you substitute it here, lambda is also minus 1. Mu is also minus 1. So what do you get? In this case, you get x to be minus 2 plus 1, it's minus 1. Y is equal to minus 3 plus 2 is minus 1. Z is equal to minus 4 plus 3 is minus 1. Substitute mu here, which x is equal to minus 5 plus 4 is minus 1. Y is equal to minus 2 plus 1 is minus 1. Z is equal to mu itself, which is minus 1. Thus you get the same point of intersection, which confirms that they both intersect and you get an intersecting point, which is also this, if they ask you for the intersecting point of intersection. So it's very easy. Okay, so example 2, show that the two lines do not intersect. X minus 1 by 3 is equal to y plus 1 by 2 is equal to z minus 1 by 5. And x plus 2 by 4 is equal to y minus 1 by 3 is equal to z plus 1 by minus 2 do not intersect. As usual, write this as lambda, this as mu. Write what is x is equal to 3 lambda plus 1, y is equal to 2 lambda minus 1, z is equal to 5 lambda plus 1. X from the second equation is 4 mu minus 2 and y is 3 mu plus 1 and z is minus 2 lambda 2 mu minus 1. Both x can be equated. 3 lambda plus 1 is equal to 4 mu minus 2. 3 lambda minus 4 mu is equal to minus 3 is my first equation. Equating both the y's. 2 lambda minus 1 is equal to 3 mu plus 1. 2 lambda minus 3 mu is equal to 2. So then you get this to be the second equation. Solving these two equations, you can multiply the first equation again into 2 and this with a 3. So it becomes 6 lambda minus 8 mu is equal to minus 6. And this will be 6 lambda minus 9 mu is equal to 6. And it's minus, plus and a minus. It becomes 1 mu is equal to minus 12. If mu is equal to minus 12, substitute and get the value of lambda. 2 into lambda minus 12 3s are 36 plus 36 is equal to 2 lambda is equal to 38, lambda is equal to 14. Substituting back in this x and y the respective values of lambda and mu, let's see if it's working out. X is equal to lambda itself is 14, 14 3s are 4 3s are 12, 3 1 3, 42 plus 1, 43. Let's find this x value from the second one. X is equal to 4 mu. 12 fours of 48 minus 2 is minus 50. So obviously you're getting two different values of x, which itself shows that it's definitely not intersecting. Okay, so that's about it. Okay. So you just find out the value of lambda and mu and then substitute and see if you're getting the same point of intersection. If you don't, then obviously you don't get the same point of intersection. It means that they're not intersecting. But lambda is minus 17. Why did I get when it goes that side, it becomes minus 36. Okay, 2 lambda is equal to minus 34. Lambda is equal to minus 17. Oh yeah. So lambda is equal to minus 17. Then you have to calculate what is mu based on that. I made a mistake here. Okay, just substitute and you get mu to be minus 12. Yeah, mu doesn't change, and you substitute there, you don't get the same point of intersection. Obviously they are not going to satisfy, and so they don't intersect. Okay, so let's go to next question. This came for a CBSE board exam. It's an example 3. Okay, where the question is r vector is equal to I plus j minus k plus lambda times 3i minus j, and r vector is equal to 4i minus k, which is 0j, plus mu times 2i plus 3k. Show that they intersect, and obviously they have to intersect. You have to solve them. You have to write it in Cartesian form from vector form. This line is x minus 1 by 3. This is 1 and this is 3. And y minus 1, x minus x1. It's 1 comma 1 comma 1 is this point. 1 comma 1 comma minus 1 is this point. So y minus 1 by j's coefficient is minus 1 is equal to z plus 1 by 0, because it's 0k, is equal to lambda. The next equation is x minus 4 by 2 is equal to, j is not there, so z minus 0 by, the j is not here to 0, is equal to, so y minus 0, z minus z plus 1 by 3 is equal to mu, because the point here is 4 comma 0 comma minus 1. The direction is 2 comma 0 comma 3. So write like this so that you can see if it's going to intersect or not. From the first equation, that x is equal to 3 lambda plus 1, y is equal to minus 1 lambda plus 1, z is equal to 0 lambda minus 1. Second equation, x is equal to 2 mu plus 4, y is equal to 0, z is equal to 3 mu minus 1. Since y itself is 0, substitute directly here. 0 is equal to minus 1 lambda plus 1. So minus 1 lambda is equal to minus 1 and lambda is equal to 1. Lambda is equal to 1 and what else you can say? This becomes 0. Z is equal to 1. Z is equal to minus 1 from this equation, because 0 lambda. Okay, Z is equal to minus 1. You put minus 1 is equal to 3 mu minus 1. The 3 mu is equal to 0. Mu is equal to 0. You're getting lambda is equal to 1 and mu is equal to 0. Substitute back in this and this and see, get the point of intersection. Lambda is 1. So x is equal to 3 plus 1 is 4. Y is equal to 0. Z is equal to, already it's minus 1. It's independent, 0 lambda. So find what is x from here. X is equal to 4, mu 0. Y is already 0. Z is equal to 3 mu minus 1. When mu 0, it's minus 1. You get the same point of intersection. It shows that the lines are intersecting. So that's about the intersecting lines. Okay. Example 4. Example 4. Find the equation of the line, two lines, through the origin, which intersect the line angle. Find the equation of two lines. Equation of two lines through the origin, which intersect the line x minus 3 by 2 is equal to y minus 3 by 1 is equal to z by 1 at an angle pi by 3. The two lines are passing through the origin and they are making an angle pi by 3 with this line. if the two lines are passing through the origin, the two lines are passing through the origin. So the diagram is like this. There are two lines which are passing through the origin. This is the origin, this one line, this is another line. Both of which are passing through the origin. But they're making a common angle of pi by 3 and a pi by 3 to the third line, which is this line, which is x minus 3 by 2 is equal to y minus 3 by 1 is equal to z by 1. So therefore, how to do this sum? You write equal to lambda. So therefore you get x to be 2 lambda plus 3, y to be 1 lambda plus 3, z to be 1 lambda itself, and that may be a point on this line which could be anywhere. You can come and consider this to be 2 lambda plus 3, a 1 lambda plus 3 and a 1 lambda, and this also could be a 2 lambda plus 3, 1 lambda plus 3 and a 1 lambda. Depending on lambda's value, it could change. Okay, what is it? A 2 lambda plus 3. So then, yeah, the point on this line, the xyz is a point on this line which can be this. Okay, so then you have to find the direction of this line then. It's subtracted 0, 2 lambda plus 3 into I plus 1 lambda plus 3 into j plus 1 lambda into k, and similar same thing occurs for this also. The directions of this line will also be the same. 2 lambda plus 3 into I. Yeah, so then but you really need to know, you got an x, y, z. How can I assume both the points to be the same? It cannot be, definitely. So let's assume that this point is only this point here. Whatever you find with this line, let's assume it's only that point. Let's not name this point yet, okay? Okay, so then therefore you get this direction. And the direction of this line is 2i, 1j and 1k. And cos pi by 3, which is the angle between the two, is the dot product of the two vectors, which is 2 lambda plus 3 into 2 plus 1 lambda plus 3 into 1 plus 1 lambda by root of this vector dot that vector, which is root of 2 lambda plus 3 the whole square plus 1 lambda plus 3 the whole square plus 1 lambda the whole square into root of 4 plus 1 plus 1. So then therefore its cos pi by 3 itself is 1 by 2. When you solve the numerator, you'll get 3 into 2 lambda plus 3. By the denominator, you'll get 6 into root of lambda square plus 3 lambda plus 3. Just try to solve it. Okay, you'll get this. Here the 2 and the 6 can get cancelled, and 3 and 3 also get cancelled. Thus the root of lambda square plus 3 lambda plus 3 itself is 2 lambda plus 3. Squaring both says lambda square plus 3 lambda plus 3 is equal to 4 lambda square plus 9 plus 3 to 6 to 12 lambda. So consolidate lambda square and everything. You get an equation 3 lambda square plus 9 lambda plus 6 is equal to 0. So cancelling entirely with the three tables, you get this to be the equation. Hence lambda will be minus 1 and minus 2. So lambda has two possibility, minus 1 and minus 2. So putting these values of lambda here. Okay, so let's put it for minus 1 and a minus 2. You get two different points, right? You get 1 comma 2 comma minus 1. If you substitute lambda as minus 1, yeah, and you substitute lambda as minus 2, what happens to this point? Minus 2, it's minus 4 plus 3, minus 1, minus 2 plus 3 is 1, and another minus 2. So this, with the two solutions that you got, you end up getting this point of intersection here, this purple colors or this blue colors point of intersection. to be this and this. There are two solutions that you get. So then therefore, the equation of OA and, okay, let's call this point as A and let's call this point as B. So then therefore, since I got 2 points, I would name one point as A, another point as B, using one condition, because the same angle I'm getting two different points, which confirms that one is A, another is B. So thus, if I want this line, I know the point is 1 comma 2 comma minus 1 now. So x minus 1 by 1 minus 1, or x minus 0 also you can write, because considering x1 y1 z1 to be 0, x minus 0 by 1, y minus 0 by 2 is equal to z minus 0 by minus 1, one equation. That's OA's equation. Similarly, OB's equation is x minus 0 by minus 1 is equal to y minus 0 by 1 is equal to z minus 0 by minus 2. So thus you get two equations. You can always ignore the zeros, and beautiful sum. Beautiful sum. I hope you all understood. It's an NCERT exam plus question. Find the equation of the line, two lines through the origin which intersects the line at an angle pi by 3, and the diagram goes like this, and this is the way you have to find this. A beautiful sum. Okay, so next question. Example 5. Again NCERT exam plus question. An AB vector is 3i minus j plus k. A CD vector is minus 3i plus 2j plus 4k. The two vectors, the position vector of the point A and C are 6i plus 7j plus 4k and a minus 9j plus 2k. Find the position vector of the point P on the line AB and the point Q on the line CD, such that PQ is perpendicular to both AB and CD. Okay, there is an AB vector. This is AB vector and there is a CD vector. The position vector of the point A and C are given. Let's see, AB vector and a CD vector. B is the point on the line AB. Q is the point on the line CD, such that PQ is perpendicular both AB and CD. Oh, so then therefore can you see from the drawing, PQ is perpendicular both AB and CD. You want a vector which is perpendicular to AB and CD. Two vectors, you can always cross them so that you get the PQ vector. Find the position vector of the point P on the line AB and the point Q. So you have to get the position vector of P and Q. You have to get the position vector of P and Q. The equation of the line AB passes through the point 6, 7, 4, and it's parallel to it will be parallel to AB vector. Yeah, this is an equation of the line passing through this point parallel to AB vector itself. So then you can write this equation to be R vector is equal to 6i plus 7j plus 4k plus lambda times AB vector 3i minus j plus k. So you got the AB vector. Similarly, CD is very easy to get, and R vector is equal to A vector which is passing through this point minus 9j, 0i minus 9j plus 2k plus lambda times CD vector which is minus 3i plus 2j plus 4k, which has been given. AB and CD are not parallel because they are not proportionals, but just that I've drawn it like this, they are not parallel. Okay, So thus you get these two vectors, two lines. And once you get the two lines, the equation of the line CD, yeah, also get. Now you have these two vectors. I'm just trying to figure out. You have this vector and this vector. And since PQ is perpendicular both AB and CD, you can just cross them and you get the PQ vector. Let me cross I, J, K. A 3, minus 1, 1. A minus 3, 2 and a 4. Let me cross it. I into minus 4, minus 2, minus J into 4 3s are 12 plus 3 plus K into 6 plus 3. So it's minus 6I minus 15J plus 9K. And thus I get the equation of this vector, the vector equation of PQ, which is minus 6I minus 15J plus 9K. I get the direction of PQ. I get the direction of PQ, which is 6, minus 15 and 9. And it's a direction ratio, it's proportional, I can also cancel it. So I got that. But to locate the point P, what do I do? The equation of this line itself is x minus 6 by 3 is equal to y minus 7 by minus 1 is equal to z minus 4 by 1 is equal to lambda. Therefore, x is equal to 3 lambda plus 6, y is equal to minus 1 lambda plus 7, z is equal to 1 lambda plus 4 will happen to be this point here, which is 3 lambda plus 6 minus 1 lambda plus 7 and a 1 lambda plus 4. Similarly, you can also find from this line, you can find this point. What is this line? It's x minus 0 by minus 3 is equal to y plus 9 by 2 is equal to z minus 2 by 4 is equal to mu. So x is equal to minus 3 mu, y is equal to 2 mu minus 9 and z is equal to 4 mu plus 2. So thus you get this point to be minus 3 mu, a 2 mu minus 9 and a 4 mu plus 2. Okay, and what can you say now? You can subtract this vector and that will be equal to minus 6. Can we say that? Minus 3 mu minus 3 lambda minus 6 is equal to, the i's and i's, when it's subtracted will give me this I, which is minus 6. So minus 3 mu minus 3 lambda is equal to 0. So mu plus lambda is equal to 0, mu is equal to minus lambda. Okay. Similarly, I can subtract the y, which is 2 mu minus 9. 2 mu minus 9 plus 1 lambda minus 7. 2 mu minus 9 plus 1 lambda minus 7. We subtract that, that should be equal to minus 15. 2 mu plus lambda, 7 to 14, 15, 16, minus 16 goes 30 plus 16 is equal to 1. You already know that lambda is equal to minus mu, or mu is equal to minus lambda, whatever. So it's minus 2 lambda plus lambda is equal to 1 minus lambda is equal to 1, lambda is equal to minus 1. So once you get that lambda is equal to, you can substitute here minus 1. You have these points here, lambda you know. So minus 3 plus 6. Minus 3 plus 6 is 3 is 1 point. And lambda you know is minus 1. 1 plus, so it becomes 8. And if you got lambda is minus 1 plus 4 is minus 3. So that P is this. Thus you get your P. And it has to be with a plus 3k. Yeah, it's a plus 3 because it's 1 lambda plus 4. Thus you find lambda. Similarly you found mu, you can find substitute there. It's lambda is equal to minus 1 means mu is equal to plus 1. Substituting here, so minus 3, 2, no, it's minus 7 because it's 9. 2 minus 9 is minus 7. Minus 7, and then it will become, this will become 4 plus 2 is 6. Thus you are able to locate P and Q. Very, very difficult sum. It's not very easy. You have AB vector and a CD vector. You have to find the point P and this point Q. It's, you know, AB vector itself, and you know A, it's also C also. Using that, you write this line and you write this line. You can write it in Cartesian form. Equate this to lambda, equate this to mu in Cartesian form. Get x, y, z in terms of lambda. You can find this vector itself because they are saying it's perpendicular to both AB and CD. When you have a vector PQ which is perpendicular both AB and CD, you can cross AB and CD, get PQ vector. Then subtract this vector and this vector's i's, j's and k's and equate it to i's, j's and k's of here. That's what I've done. I hope you're clear. Very, very beautiful sum. Okay, please learn this. So let's go to next question. Next question that I taught these guys is to find the foot of the perpendicular. Example 1. Find the foot of the perpendicular from the point 0, 2, 3 to the line x plus 3 by 5 is equal to y minus 1 by 2 is equal to z plus 4 by 3. To find the foot of the perpendicular means this foot. You normally mark it as lambda, so x is equal to 5 lambda minus 3, y is equal to 2 lambda plus 1, z is equal to 3 lambda minus 4. Thus you get this foot of the perpendicular to be 5 lambda minus 3, 2 lambda plus 1 and 3 lambda minus 4, and hence you can find this vector now because you know the foot now. So what is this vector? It's x2 minus x1 into I. 5 lambda minus 3 into I minus 0, so it's okay. 2 lambda plus 1 minus 2 into j plus 3 lambda minus 4 minus 3 into k. So this becomes a 5 lambda minus 3 into I plus 2 lambda minus 1 into j plus a 3 lambda minus 7 into k. You know now this direction you got, that and this below one will be perpendicular because it's foot of the perpendicular, and so this line dot product them. So 5 into 5 lambda minus 3 plus 2 into 2 lambda minus 1 plus 3 into 3 lambda minus 7 is equal to 0. Hence you can find what is your lambda. So that's what we're going to do. So then it's 25. 5 into 5 lambda minus 3 plus 2 into 2 lambda minus 1 plus 3 into 3 lambda minus 7. When you solve it, you get lambda to be 1. Once you get lambda to be 1, you can substitute in the foot of the perpendicular. This is the foot of the perpendicular. When you know lambda is 1, it becomes 2, a 3 and a minus 1 will become the foot of the perpendicular. This is the way to find the foot of the perpendicular. The same question they might extend and ask you to find the image. Okay, they ask you to find the image. You found the foot of the perpendicular. The image will be exactly here. You can call it as LMN, and it will be midpoint between this and this will be this. Midpoint formula x1 plus x2. 0 plus L by 2 is equal to 2. So L is equal to 4. Then 2 plus M by 2 is equal to 3. x1 plus x2 by 2 is equal to this midpoint. 3. So 2 plus m is equal to 6, so m is equal to 4. Similarly, 3 plus n by 2 is equal to minus 1. 3 plus n is equal to minus 2. So n is equal to minus 2 minus 3. N is equal to minus 5. Thus you get your L, M and N, which will be the image. The question is about image. That answers your image question. I hope you all understood how to find the foot of the perpendicular. Okay, and the image. Okay, there are sums. Example 4, find the image of the point 1, 6, 3 in the line x by 1 is equal to y minus 1 by 2 is equal to z minus 2 by 3. Please do those sums and see if you are getting. And also they are asking you to find the distance, the length of the perpendicular. Length of the perpendicular. Okay, let me do the example 4. 1, 6, 3. to the line x by 1 is equal to y minus 1 by 2 is equal to z minus 2 by 3 equated to lambda. The foot of the perpendicular is what they want. Okay, foot of the perpendicular, x is equal to 1 lambda, y is equal to 2 lambda plus 1, z is equal to 3 lambda plus 2, and write it as the foot, which is 1 lambda, 2 lambda plus 1 and 3 lambda plus 2. Now write this vector, which is x2 minus x1 into I. So 1 lambda minus 1 into I plus 2 lambda plus 1 minus 6 into j plus 3 lambda plus 2 minus 3 into k. So it will become 1 lambda minus 1 into I plus 2 lambda minus 5 into j plus 3 lambda minus 1 into k. Thus you found this vector. You know this and the below vector here are perpendicular to each other. So then therefore dot product them, 1 into 1 lambda minus 1 plus 2 into 2 lambda minus 5 plus 3 into 3 lambda minus 1 has to be equal to 0. So when I write that, I'll get what is lambda, what has to be lambda. So 1 lambda minus 1 plus 4 lambda minus 10 plus 9 lambda minus 3 is equal to 0. Solving all it, it's 14 lambda. This will be minus 14 is equal to 0. So lambda is equal to 1. Giving 1 as lambda here, 1, 3 and 5 are my foot of the perpendicular. I found the foot of the perpendicular. I know how to find the image now. Once you get the foot of the perpendicular, I told you how to find the image. That forget about it. The equation of the perpendicular. If you have, they ask you the equation of the perpendicular. It's passing through 1, 6, 3, and the foot of the perpendicular is 1, 3, 5. You know 2 points. So it's x minus 1 by 1 minus 1 is equal to y minus 6 by 3 minus 6 is equal to z minus 3 by 5 minus 3. So this gives you the equation, the Cartesian equation of the line, but find the length of the segment. So if they ask you the length of this line, blue color line, it's a root of x2 minus x1 the whole square, root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square, the root of 1 minus 1 the whole square plus 3 minus 6 the whole square plus 5 minus 3 the whole square. So then whatever that answer is, it's the root of 9 plus 4. So it's root of 13. So that will be my distance, and that will be this distance. They ask me the distance between the point and the image. I just have to double it. So it's 2 root 13. I hope you understood. So these are the ways in which they can twist and turn the questions and ask you. Still should be able to manage and answer that. Next is supposing they ask you sum number 13, page number 28.30. The distance of the point 2, 4, minus 1 to the line x plus 5 by 1 is equal to y plus 3 by 4 is equal to z minus 6 by minus 9. It's not, it's not, I don't know, would it be the perpendicular distance? They say distance. Could be, okay, so let's see, equal to lambda, so x is equal to 1 lambda minus 5, y is equal to 4 lambda minus 3, and z is equal to minus 9 lambda plus 6, and therefore this will be this points here. And you can, as usual, considering it as perpendicular distance, otherwise it's not possible to solve it. So find this vector. It's 1 lambda minus 5 minus 2 into I plus, one second, hold on. So coming back to what I was doing, yeah. So get this directions. 4 lambda plus minus 3 minus 4 into j, minus 9 lambda plus 6 plus 1 into k. So it will be 1 lambda minus 7 into I plus 4 lambda minus 7 into j plus minus 9 lambda plus 7 into k will be the direction of this, and this direction and the denominator of this line can be dotted. So we have to treat it as perpendicular only, otherwise we can't do it. So 1 lambda minus 7 plus 4 into 4 lambda minus 7 minus 9 into minus 9 lambda plus 7 is equal to 0. 1 lambda minus 7 plus 4 4 is 16 lambda minus 28 plus 81 lambda minus 63 is equal to 0. 1 lambda, this will add up to 82. 82 plus 16 is 98 lambda. This minus 35 minus 63 minus 35 is 8. Oh, minus 98 is equal to 0, 98 lambda is equal to 98 and lambda is equal to 1. So then substituting here you get the point of intersection, this point foot of the perpendicular. So lambda is equal to 1, x is equal to minus 4, y is equal to 1, z is equal to minus 3. So then what's the question? The question is about the distance. So you know this point now and this point. So root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So it's minus 4 minus 2 the whole square plus 1 minus 4 the whole square plus minus 3 plus 1 the whole square, and whatever that value is. I hope you all understood how to find the same principle, right? Nothing new. So this gives you clarity on how to do the image sums, how to approach image sums. And okay, so then next is shortest distance between two skew lines. I've already taught you how to do that. And so then let me tell you, since you know how to find the shortest distance between two skew lines, it's a2 minus a1 dot b1 cross b2 by magnitude of b1 cross b2, and this is the formula to find the distance between two skew lines. Between two skew lines. Skew lines means one on the floor, another on the wall. Can you imagine? So if two lines have to be coplanar, two lines are to be coplanar, means they have to lie in the same plane. The skew distance have to be equal to 0. So therefore this formula has to be equal to 0, and so a2 minus a1 dot b1 cross b2 is equal to 0 is the condition for two lines to be coplanar. When a line is given, you can identify what is a1, a2, b1, b2, and then just put this, and if a2 minus a1 dotted with b1 cross b2 is equal to 0, then it means it's coplanar. Very, very important. They'll ask you this. Okay. So the next thing that I want to discuss is page number 28.38. This is sum, which is the board exam sum. Second sum, second subdivision. X minus 1 by 2 is equal to y plus 1 by 3 is equal to z. What is the meaning of z? It means z minus 0 by 1. You all know now. So that is fine. Next is x plus 1 by 3 is equal to y minus 2 by 1. Colon z is equal to 2. Here is where the danger is. They'll ask you this question with a colon symbol. When there's a colon symbol, it means it is z minus 2 by 0. That's when if you equate it to lambda, z will be itself equal to 2. So you should understand, when you are writing this equation, it's x plus 1 by 3 is equal to y minus 2 by 1 is equal to z minus 2 by 0 is equal to lambda. I hope you understand how to convert it. Very, very important sum. The next equation, so the first equation has been given, which is a straightforward equation. And this is the second equation. This is equal to lambda and this is equal to mu. What is the question? They are asking shortest distance. You just have to identify what is your a1. a1 is 1i minus 1j plus 0k. What's your b1? Is 2i plus 3j plus 1k. The line is in the right format? Yes. Then a2 is 1i plus 2, minus 1i plus 2j plus 2k, and a b2 is 3i plus 1j plus 0k. So you have an a1 b1 and an a2 b2. Then directly the question of finding the skew distance is a2 minus a1 dot b1 cross b2 by magnitude of b1 cross b2, and that's what you do, and the whole modulus will give you the skew distance between the lines. And the question, the trick about it is z, colon z is equal to 2, and that's what is going to make things complicated for you. Otherwise every sum is the same. To check if the two lines are coplanar, as I told you, this has to be equal to 0, and so then a2 minus a1 dot b1 cross b2 itself is 0 is the condition for two lines to be coplanar. Okay, so I'm sure you understood everything. You can this sum also so beautiful, the 21st sum in page number 28.42, where find the angle between the line 2x is equal to 3y is equal to minus z, and 6x is equal to minus y is equal to minus 4z. You cannot possibly have an equation like this. You have to take this and convert it as divide throughout by 2. So x minus this is actually, so you cannot possibly have a question like this. So you can understand this means it's 2x minus 0 is equal to 3y minus 0 is equal to minus z minus 0. And you don't want a 2, it's x minus 0 by 1 by 2. y minus 0 by 1 by 3 is equal to z minus 0 by minus 1. Z plus 0 doesn't matter, by minus 1. So thus you convert this equation. Second equation also should be converted. It's 6x minus 0 is equal to minus y minus 0 is equal to minus 4z minus 0. So you have to go dividing throughout by 6. 1 by 6. Both the numerator and denominator by 6. Minus can be taken out. Y plus 0 by minus 1 is equal to minus throughout can be taken out. Minus 4 itself can be taken out. Z plus 0 by minus 1 by 4. Thus you convert this equation into an ordinary form. Once you get that, the angle between the two lines, for you need a b1 vector and b2 vector, which is 1 by 2i plus 1 by 3j minus 1k, and a b2 vector is 1 by 6i minus 1j minus 1 by 4k. So the angle between the two vectors is cos theta is b1 dot b2 by magnitude of b1 into magnitude of b2. b1 dot b2 is 1 by 12 minus 1 by 3 plus 1 by 4 by magnitude of b1 is 1 by 4 plus 1 by 9 plus 1, and the magnitude of b2 is 1 by 36 plus 1 plus 1 by 16. I hope what I'm doing is right. I want the answer 21. Okay. So can you see if I'm going to take LCM in this? 4 3s are 12. This is 4 into 3. So it's 1 minus 4 plus 3, which itself will lead to 0. The angle between the two vectors is 0. Shows that the two lines are perpendicular to each other. Therefore, angle theta itself is pi by 2. Okay, so what I want you to do is take every sum in the textbook, which are in the examples of straight lines, of equation of a line in a 3D. Do everything and ask me doubts if you have. Just finish all this, and plane is omitted, so that's about it, guys.